Welcome students again to ISIFE EDUBLOG. I am your physics teacher, Stephen Chus. Today we are going to talk about the mirror formula, that is the calculation part of curved mirrors. Please, before we continue, if you are new to our channel, don't forget to subscribe, share, and give it a thumbs up. So let us forge ahead. The mirror formula. Here, we are going to talk about the formulas for solving questions under concave mirror and the formulas for solving questions under convex mirrors. But before we continue, you have to remember again that a concave mirror is a converging mirror and a convex mirror is a diverging mirror. Now, concave mirror being a converging mirror, you have to notice again that for a concave mirror, this is a concave mirror, the focal point and the center of curvature are in front of the mirror, making it positive. But for a convex mirror, this is a convex mirror, convex, and this is concave. So, for concave mirrors, the focal point and the center of curvature are in front of the mirror. That means that F is always positive, but for convex mirror, the focal points are behind the mirror. That means that for convex mirror, F is negative. You have to take note of this. Now, we talk about real images and virtual images. Whenever the image formed is real image, they must be what? Positive. But virtual image must be what? Negative. So, you have to know all these things before we forge ahead to the mirror formula. Okay, as you can see here, these are the different types of ways images can be formed. Let us start from the first one. What is the formula for when a concave mirror forms a real image? Whenever a concave mirror forms a real image, it is going to be 1 over F. Remember, the F is positive because it is a concave mirror and the focal length is in front of the mirror. It is going to give us 1 over U. U represents the object distance. Object distance is always positive because before an image can be formed, be it concave or convex, the object must be in front of the mirror. And anything in front of the mirror is positive. So when a concave mirror now forms a what? Real image, the image distance should also be what? Negative. So F is focal length, U is object distance, and V is image distance. Let's take a look at number 2. When a what again? Concave mirror now forms a what? Virtual image. We are going to write the same formula, but something is going to change because this is real and this is virtual, even though both of them are concave mirror. So for being a concave mirror, the focal length should be positive. The object distance should also be positive, but because it is a virtual image, the image distance now becomes what? Negative. So this is 1 over F equals to 1 over U plus 1 over V, while this is 1 over F equals to 1 over U minus 1 over V. Finally, when a convex mirror forms an image, if you remember again, only one type of image is formed by a convex mirror, and that image must be virtual. Now, for a convex mirror, remember that the focal length is behind the mirror, therefore making the focal length to be what? Negative. That is minus 1 over F equals to U must always be what? Positive because it is the object distance. But because it is convex, whenever you hear convex, the image must be what? Virtual. And hence, image distance must be minus 1 over V. So these are the different types of formulas that can be applied depending on the question that is given to you. Now, most times what external exams like WAEC or JAM does is that they don't call it virtual image or real image for you. It is now left for you to know when it is virtual and when it is real. Let me tell you, whenever it is concave mirror, F must be plus. How do we know real images? By taking a look at the distance of the image and the focal length. If the focal length is, for example, 10 cm and it is concave, from those diagrams we did, the three diagrams that gave us real images are when the object is beyond center of curvature, which means object distance is greater than F. When the object is at center of curvature, which means object distance is also greater than F. And when the object is between F and C, and object distance is also greater than F. So whenever U in a concave mirror, whenever in the question U is greater than F, that's the image form must be real. The image form must be real. Take note of that. Now, for a concave mirror, when the only time it forms a virtual image is when the object is between the focal point and the pole. And you can see that here, the focal length is now more than the object distance. This is the object distance. And hence, for a concave mirror, whenever U is less than F, the image form must be virtual. So whenever U is greater than F and it is concave, we make use of this formula. Whenever U is less than F and it is concave, we make use of this formula. Now, whenever it is convex, whether U is greater than F or F is greater than U, we must use this formula because only one type of image will be formed. So let us take a look at magnification of curved mirrors. Magnification, again, as we know from the pinhole camera, is the ratio of the image distance to the object distance. It is also the ratio of the image size to the object size. Hence, here, magnification is V over U, which is also equals to HI over HO. So magnification is image distance over object distance, and it is also equals to image height over object height. So let us take a look at another formula for magnification when a concave mirror forms a real image. Please remember that 1 over F is equals to 1 over U plus 1 over V. And M magnification is equals to V over U. So what do we do here? What do we do to get V over U? It is by using this point. If we put V here and it becomes V over U, it automatically becomes magnification. And how do we put V here? We multiply through by V. When we multiply through by V, this one is going to give us V over F equals to V over U plus V over V. So we have V over F equals to, wherever we see V over U, it means magnification. So at this point, this V over U becomes the magnification plus V over V is going to give us 1. So if we make M the subject of the formula, plus 1 we cross equality sign to become V over F minus 1 equals to M. And therefore, another formula for magnification where only for image distance and focal length is given is V over F minus 1. And please, take note, this is the formula for magnification of a concave mirror forming a real image. Thank you very much.